So, at some point, consciousness had to come into this. And I can think of no one better to introduce consciousness at this point, especially because of the, at least at the level at which Stuart wants to talk about it, and because of his work with Roger Penrose as well. Then Stuart Hameroff. Stuart Hameroff is anesthesiologist, director of the Center for Consciousness Studies at the University of Arizona. And some of you here must have been to these Tucson conferences on consciousness. And Stuart was the lead organizer for those things, and did a fantastic job of really getting us all thinking about these sorts of issues. He has collaborated with Roger Penrose on the development of what they call the OR theory of consciousness, which he may well explain in passing. And I think you're going to connect everything that's been spoken about so far into one little package, right?
I'm going to try.
Okay.
Thank you, Roger. Thanks for inviting me. Thanks for still being here, everybody. Well, so far, to my way of thinking, most of this conference has been kind of like the Inquisition, but in reverse. The scientists are kind of frying the people who believe in religion. And I personally am not fond of organized religion, and I don't have a problem with bashing organized religion. However, I think that there is room in science for scientific spirituality, basically an interconnectedness, a reservoir of Platonic ethical values embedded in the fundamental level of the universe. This is the idea that Roger Penrose put forth in The Emperor's New Mind. And he doesn't go so far as to relate it to anything spiritual or religious, certainly. He kind of stops. But I think it's fair game to take what he said and extend it to some kind of underlying aesthetic and ethical Platonic values embedded in the fine structure of the universe. But then one must show how this level can connect to our relatively macroscopic brains. So with that in mind, the title of my talk is somewhat tongue-in-cheek, Quantum Consciousness Can Save the Soul. By soul, I mean this kind of spirituality, interconnectedness, and Platonic values embedded in the universe. So Descartes, of course, prior to Descartes, religion and science were pretty much on the same page in most things. And then Descartes, who said, of course, I think, therefore I am. The fact that he was conscious was the only thing he could be absolutely certain of. But consciousness, as we all know, is unobservable. So this gave rise to dualism. And it's kind of continued, actually. Those in neurosciences tend to explain away a lot of the things about consciousness. So the scientific aspect of this led to what we might lump as neurocomputation, basically brain equals mind equals computer, in which neuronal axonal spikes, synaptic transmissions are fundamental components like bit states and switches in computers. And some of the giants in that field are in this room. And this is based on dendrites receiving inputs from an axon, integrating and then firing to the next one. And with the chemical synapse being the fundamental unit in most ways of looking at it. However, as an explanation for consciousness, this view of neurocomputation has some problems. First of all, it is incompatible with the best measurable correlates of consciousness, gamma synchrony EEG, and the mechanism of action of general anesthesia. Also, it necessitates rendering consciousness as an after-the-fact illusion, an epiphenomenon with no causal power. As Thomas Huxley said, we are merely helpless spectators. And it precludes any scientific possibility of non-local interconnectedness, fundamental morality, and deeper meaning, the soul. Now, we could argue endlessly about these two things. And we've heard arguments that there is no such thing as a soul, and all this is a bunch of rubbish. And maybe we are helpless spectators and don't have any real-time conscious control. Maybe consciousness is an illusion put together after the fact and inserted in a memory, as Dan Dennett has described it. And it's difficult to prove either way on this, as we've heard. However, let's look at the science. Let's look at these problems that I'm claiming exist with neurocomputation for gamma synchrony EEG and general anesthesia. Now, in addition to chemical synapses, there's another type of electrical synapse in the brain and nervous system, electrotonic gap junctions. These are electrical synapses. They form between dendrites, dendrite to dendrite, for example, also glial cells, and in some cases axons. And they make a different type of network within other networks within the brain. Here's a close-up, but you don't actually see it, but these are hollow cores. So these gap junctions are like docking modules between spaceships, if you will, so you could swim, if you're really small, from one neuron to the other. And these are, of course, the microtubules where Roger and I think consciousness is actually happening. But the point is that these electrotonic gap junctions are what mediate gamma synchrony. Specifically, dendritic gap junctions mediate gamma synchrony, the best neural correlate of consciousness. They form what you might consider as dendritic connections or lateral connections, shown here in this slide from Cahal's early work, and then dendritic interactions between pyramidal cells and interneurons and others in the cortex. So and they come and go. They form a connection, they disappear, they come and go. So transient webs of dendritic gap junction connected neurons and glia can extend widely through cortex, and they mediate gamma synchrony. And I claim that this is the neural correlate of consciousness, these transient webs. And this idea was put forth by Sir John Eccles and Carl Prevram, that consciousness occurs in dendrites with axons providing input to and output from where consciousness is occurring. So if we look at a regular group of neurons with dendrites here, fire a spike, trigger this one, goes around in this circle. Obviously, there could be a lot of parallelism and so forth. But just if you were measuring, you'd see this voltage potential kind of traveling around. There's no coherence. Spikes are not coherent. However, the dendritic gap junction connections do give rise to gamma synchrony. So anywhere in the system where you measured, you'd see gamma synchrony. Where you had the dendritic gap junctions, there could be some glia involved, and so forth. So the point is, the best neural correlate of consciousness, gamma synchrony, depends on dendritic gap junctions, not neurocomputation as we normally think of it. I'm an anesthesiologist, and I put people to sleep every day and wake them up. And the best study that I've seen on brain monitoring during anesthesia and loss of consciousness was done by Eroy John and Leslie Pritchup last year. And they showed that loss of consciousness with general anesthesia correlates with loss of gamma synchrony between frontal and occipital cortex. So here's the absolute power in F3 and O1. So a frontal lead and an occipital lead. And just to cut to the chase here, if you look, this is induction. So the patient's awake, they go to sleep, loss of consciousness, they're maintained under general anesthesia, they begin to return to consciousness, and then they're fully awake. And the one thing that stands out, as you can see here, that correlates with consciousness is the coherence between the front of the brain and the back of the brain. And this is quite robust, and it's been repeated in rats, and of course we don't know for sure the rat is conscious when they wake up, but the point is that front to back and cross-hemisphere coherence in the gamma synchrony range is the best correlate of consciousness. Now, gamma synchrony derives from coherent conformational oscillations of dendritic membrane proteins regulated by quantum London forces. So what I'm saying is that if you have dendritic membranes in different parts of the brain oscillating coherently, that means their voltage channels are oscillating coherently, and they are anesthetic sensitive proteins, and that means that their conformational state is controlled by electron dipoles within what are called hydrophobic pockets. And if they're in one orientation, the protein is in one shape. This could be an open channel, this could be a closed channel. It goes back and forth, coupled to the movements of these electrons. And these are quantum mechanical forces. Anesthesia, anesthetic gases work only by quantum forces. They form no chemical bonds in the body, and they're also quite selective. Patients under general anesthesia are unconscious, but if you do evoked potentials or measure EEG, their brains are quite active. We use evoked potentials all the time in spine surgery, and the brain is neurocomputing away in the absence of consciousness. What does disappear only is the gamma synchrony. And so anesthesia is selective for consciousness, sparing other brain functions, and they bind only by quantum interactions, quantum forces called London forces. So the other problem with gamma synchrony is that besides it not being mediated by conventional neurocomputation, it is not driven by thalamocortical pacing, recurrent feedback, reciprocal action potentials, and or synaptic transmissions. As I said, gap junctions, while necessary, cannot account for the zero phase lag coherence, the perfect, as far as one can measure, between front and back. So here we have gamma synchrony, and basically what's happening is that proteins in the front of the brain are oscillating coherently, and proteins in the back of the brain are oscillating coherently. And Walter Freeman and Giuseppe Vitiello, and in a separate paper, E. Roy John, concluded that normal neural processes shown here cannot account for this synchrony, and that some quantum effect must be at play in the brain to account for gamma synchrony. And even if you deny that gamma synchrony is the best neural correlate of consciousness, it does occur, suggesting that something funny is going on. And quantum correlations, entanglements between the front and the back of the brain, mediate gamma synchrony and consciousness. And Walter was, as you probably know, is no big quantum fan. He just came to this conclusion by studying it. And I recommend this paper. Actually, I didn't put the citation, but I can send it to you. Anyway, proteins switching between two states, depending on quantum forces in their core, is the basis for the model that I developed with Roger Penrose, in which microtubules inside the neurons, particularly within dendrites, are performing quantum computations with themselves, with each other, and through gap junctions throughout the brain to account for consciousness. So if we were in this neuron looking through the gap junction, we'd see this other neuron. And if there were another gap junction here and here and here, this could spread throughout the entire brain. And one could have one continuous interior where quantum states could be protected and isolated and avoid decoherence. And this is something what it might look like with quantum states spreading between, from neuron to neuron through a gap junction. So that was the story about anesthesia and gamma synchrony, which neurocomputation has a problem with. The other issue that I want to address that's more arguable in both directions is, are we helpless spectators? It's been known for many years. Max Velman's published in 91 on this, and Dan Dennett had it in his book in about that time. Evoked potentials apparently occur too late, 150 to 500 milliseconds after sensory impingement, to account for responsive actions initiated or completed within 100 milliseconds. So in other words, by the time we figure out what somebody said, or by the time we figure out what's happening, we've already responded. Normal conversation, choice planning of execution of voluntary acts, hitting a baseball pitched at 95 miles an hour. A guy wrote a book that says it's impossible consciously, even though the batters think they see the pitch at least halfway. So consequently, so subjectively, we feel as though we perceive and respond to these perceptions consciously. Consequently, subjective feelings of conscious control of these behavior is illusion. They are merely non-conscious reflexive responses. Dan Wegner, Dan Dennett, Terry Serjanowski said something to that effect in the U.S. News and World Report article a couple weeks ago. Accordingly, consciousness, according to the party line, neurocomputation, is epiphenomenal. And we are, as Huxley said, conscious automata, helpless spectators, like Pac-Man. We're being controlled by, in this case, our unconscious selves, and we only think that we're conscious, and it's imprinted in the memory that we were in control. That's Dan's idea. So is there any hope? Well, yes, and there's also data. And this is very old data from Ben Libet, and many people in this field are familiar with this set of experiments, which still defy easy explanation. Basically, he had patients having neurosurgery, craniotomy, with their brain exposed, but under local anesthesia so he could talk to them. And for example, he could stimulate the finger area of one cortex and also the same finger on the other side. And basically what he found was that direct cortical stimulation, if it resulted in what looks like gamma synchrony for 500 milliseconds, resulted in consciousness at the end of half a second. But if you stimulated the finger and got an evoked potential followed by 500 milliseconds, it was felt at the time of the evoked potential. Now he did some other studies with thalamic stimulation, which basically said that if you have the evoked potential but don't continue with the gamma synchrony for the full time, there's no conscious experience. So somehow it appears as if the brain or the body or somebody knows whether or not this is going to continue. Libet concluded that there's backward time referral of subjective experience from the time of what he called neuronal adequacy to the time of the evoked potential. Now, backward time is perfectly permissible for quantum information, quantum mechanics. To put it in another context, we know that the brain fills in, constructs reality. For example, in the color phi phenomenon. Many of you are familiar with this. You look at a screen, you see red on the left, then nothing, then green on the right. What you experience is red turning to green halfway across. That's what you experience. Okay, no big deal. However, if you do this 20 times in a row, and the 21st time, you trick the subject and it goes red, red, the brain isn't fixed. It goes red, 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 red. Or if it's blue, it goes red, red, blue, blue, blue. Somehow, it seems as though the brain knows what's going to happen. Now, there's a couple explanations for this. Now, I've turned this sideways. So here's the observer looking at the screen this way, with time going this way. So here's red over here, green over here, subsequent in time. So this is what is actually happening. Now, what the observer experiences consciously is red turning to green halfway across. That's just what I just said a moment ago. Now, in Dennett's explanation, retrospective construction or Orwellian revisionism or Stalin-esque show trials, they're all nuances of each other. What he says is that in real time, there's the red and then there's the green, but the observer remembers red, red, green, green, green. So the observer, the conscious observer, is roughly a half a second behind reality. We're living in the past, and we falsely remember unified conscious experience occurring in real time. And this is his position, and this is pretty much everybody's position in mainstream neurocomputation, I believe. However, another possibility is that because quantum information can go backward in time this way, that the signal can actually come from the near future to the present so that we can have real-time conscious experience. Now, backward time it is strange, but in quantum information, it happens all the time. And in fact, it's probably what mediates EPR effects and entanglement, that the signal when the measurement is made goes backwards in time to when they were united and then to the other one. So backward time effects in quantum mechanics is okay as long as there's no causal paradox, as long as nothing goes back in time to kill your grandmother so you can't be born. If you avoid those causal paradoxes, it's not a problem. And since the quantum information is unconscious in our model, then it can't be observed, so there's no causal paradox. So quantum consciousness can get us out of this problem of being a half a second behind reality, living in the past, and having consciousness be an illusory epiphenomenon. So there's been very little said about the quantum world here. Let me just survey a couple things. Basically, reality is described by two sets of laws. We heard about Isaac Newton this morning, but after, starting about 100 years ago, quantum mechanics came in, and physicists thought they had it all figured out. Well, it turns out it was far from the truth. In the quantum world, quantum particles can exist in multiple states or locations simultaneously, quantum superposition, and this is used in quantum computing. Wave particles may remain unified over distance and time, quantum entanglement. And recent studies have shown that entanglement occurs at room temperature or warmer robustly, and that macroscopic objects can be entangled. So it's becoming more and more prevalent, even in semiconductors at room temperature, to have quantum entanglement. And quantum information is time symmetric, backward time. Many people say, well, the quantum world is random. That's not true, at least not necessarily true. Measurement and decoherence introduce randomness, though the quantum world itself is not random and highly ordered. Otherwise, entanglement couldn't work, for example. So the third problem, is there a scientific possibility for non-local interconnectedness, fundamental morality, and a deeper meaning? But I just lump as the soul. And basically, Roger proposed that a Platonic realm of truth, ethical, and aesthetic values exist in the quantum geometry of the universe at the Planck scale. And Freeman Dyson said something similar. Mind and intelligence are woven into the fabric of the universe. So here we have space-time curvature correlating with mass at obviously a large scale. This looks like planets, but it could be at any scale. And in fact, curvature correlates with mass even at small scales, and superposition correlates with separation at this scale. So in our quantum model, we make an argument that this type of quantum computation connects our conscious processes to this fundamental level of the universe. And what we have is a sequence of discrete events of pre-conscious quantum superposition occurring at 40 hertz, 25 milliseconds, and so forth. And so we have a sequence of conscious nows, conscious moments, consistent with William James' idea of stream of consciousness and specious moments, and many other people who said the same thing. When movies came along in the 20th century, realized that they were discrete frames but perceived as continuous. And even Christoph Koch, with whom I disagree a lot, he and I agree that consciousness is a sequence of events, and we think they're a sequence of quantum state collapses mediated by Roger Penrose's objective reduction, which is a process actually occurring in the fundamental level of space-time geometry. And every time there's a collapse, there's an objective reduction, quantum information can go backwards. So this would allow for real-time conscious control of our actions. So our actions might be influenced by Platonic values embedded in Planck scale quantum geometry. So this is a figure I used in an article a few years ago where we have a robotic, algorithmic windsurfer who might be aiming for port B, but every once in a while winds up in A or C because of the Platonic non-computable influences shown here as the wind, but in actuality in our model would be Platonic information embedded at the fundamental level of the universe in the Planck scale. Well, what does that look like? Well, nobody knows for sure, but basically what I'm saying is that these types of things, the Jung collective unconscious, Buddhist luminosity, Vedic descriptions of Godhead, divine guidance, the wisdom in Kabbalah and so forth, all these kind of metaphysical baggage that was referred to earlier could actually be there embedded in the fundamental level of the universe, which can be described possibly through loop quantum gravity, spin networks, twisters, string theory, quantum geometry. String theory, you need a background. So by itself, it's probably enough. It's probably not enough. So the best bet is probably one of these, loop quantum gravity. And this is actually an image of what the Planck scale might look like in quantum geometry, where each of these volume voxels is the edges are average on a Planck length. 10 to the minus 33 centimeters. And this is the best picture that we have of what the universe looks like at its most fundamental level. So the potential for information is vast. There's 10 to the 107th of these volumes in our head. And the permutations is just incalculable. And it's non-local. So wherever you go, the same pattern is going to repeat at some scale. So in conclusion, quantum consciousness can account for anesthesia and gamma synchrony, which I claim neurocomputation cannot, and I'd be happy to hear rebuttal from neurocomputationalists. It can also account for real-time unified experience and conscious control, and it can provide a connection to a deeper reality of quantum Platonic information embedded in the universe. And one more point, P.S., the same argument applies to evolution. The pi stack in DNA is a nonpolar quantum environment, thus mutations may also be subject to non-computable Platonic influences. So I'll end there, and thank you for your attention. Some questions?
I think there's bound to be some questions on that. You seem to have enraged just about everybody with the
that was my plan.
Scale. Lawrence, you're just bouncing out of your seat, aren't you?
I don't want to be confused with Richard Dawkins here, but I think as from a physics perspective, I think everything you said is nonsense. And maybe I'm being too polite, but I see, I cannot, there's no way in which I could see to get quantum coherence, you need very, very carefully prepared states with no external interactions at all, and I can't see a system that's less like that than the human brain or the human body, where there are interactions. But hold on. But the other thing about this quantum information going backwards in time is just the way you said it is just not true. I mean, we can talk about it later, but you're just wrong. Okay.
Well, excuse me, but your first point is, yeah, the brain's too warm and wet and noisy, none of which are true. Recent reports have shown room temperature, macroscopic, quantum spin transfer, quantum states, And biological studies have shown enhanced quantum spin transfer with increasing temperature through organic molecules, the same type of aromatic amino acids in the core of the proteins. And so it's not true that it's a priori impossible. And in fact, David Aushalom at UC Santa Barbara continues to show more and more warmer and warmer macroscopic quantum state reductions. And entanglement occurs all the time without decoherence. Now, the other thing about backward time, it'd be more correct to say that in the quantum world there is no flow of time. We're in the Well, hang on. There's a lot of people who disagree. A lot of physicists. I'm not a physicist. Roger made this claim. Aharonov has made the same claim of the dual vector theory with each collapse sending quantum information backwards in time. Feynman has a backward time effect in classical. So that's not true. What does that mean? Is quantum information the unconscious? Is that you're saying?
Well, no. If you haven't got a mic, it's not going. It's just going into the ether. So no, I mean, we can't hear you without the microphone. And I know that's important to you, Lawrence. There is an issue here, which is there was an issue of U.S. News and World Report that Stuart just mentioned on the science of the soul, I think it was called. And you were in the piece. You also mentioned that Terry was there. There was some. Would you like to say something from the neurocomputational perspective on this?
Well,
I mean, go and say it. It's fine.
Okay. Yeah. So yeah, since you did raise my name in vain, I thought it would be only fair to.
I was hoping you'd comment.
And I want to make this a general point, and not just to respond to the lecture, and that has to do with what we now know about mechanisms in the brain. We're still at a very early stage. We see a wide variety of signals. 40 hertz signal is a particularly interesting one because you see it not just during the awake state, but also during sleep. In fact, the original experiments done in Wolf-Singer's lab were anesthetized cats.
Ketamine.
And I think our understanding of those signals is, like I said, still very early days. We just don't really have enough knowledge yet to know either their significance or their biophysical mechanisms. So I just want to lay that on a table that we just don't know. I personally wouldn't bet on this one. But that having been said, one of the issues that came up earlier today was the issue of reason and logic in providing us with tools and techniques in science to actually get to the bottom of a problem and solve them in a way that you can really be confident of. And this is something that Francis was echoed in the quotes that I gave earlier. So humans aren't very good at reasoning. I mean, it is true that, after a lot of training in a particular field, you can get pretty good at, figuring out the right control experiments and figuring out exactly what you need to do in order to prove it. But often that doesn't even transfer to other fields. You can easily make mistakes. And physicists are very good at this, by the way, when trying to debug the mystic, Uri Geller, right? It was two physicists that were taken in because they just didn't know anything about magic. They didn't know the right questions to ask. And in some ways, physicists are
Terry, I'm
pretty
not
good at
bending
reasoning.
spoons. Please.
No. I'm sorry. I didn't mean to imply that. Although,
or you're implying that I don't have reason.
No. I'm just making a general point about reason, and I'll get back in a moment to the issue. Where I think rationality and reason really shine is in being able to go step by step through the evidence that you have, putting together rational arguments, and writing a paper. But is that actually how we make discoveries? Right? If you read a paper, you'll never figure out how they actually got to the point. And we all know, working scientists know that often it's an accident Or often it's an idea you had in the shower. Where do those ideas come from? They're not deductive. Often they're inductive from a lot of experiments and experience, and something clicks, and it's not something that you can program. It's not a computer. And what do you call this? Well, unconsciousness is kind of the grab bag for things that you're not aware of, things that are happening at a level in the brain where we don't have conscious access. And ultimately, that's where intuition comes from, and new ideas. And I think it would be a mistake to ignore that and to shove it under the rug. I mean, we're cool calculating scientists. We do things logically. We make deductions. It's true, that's one aspect of proving it to your colleagues, but that's not the whole story for science. And I think that we're using our brains in perhaps the same way that ordinary people, not ordinary people, I'm sorry, that humans use for solving problems in their everyday life. Pat Churchland tells this story that she teaches freshman logic, and it takes them a whole quarter to learn modus ponens. But these are students who are spectacularly good at solving social problems. Right? They can figure out what's happening with other people and other groups, and they're really, really sophisticated in the narrow regime of social interactions. And it's clear that our brain has a lot of circuits in it. And I think
Terry, excuse me. I got to catch a plane, and what does this have to do with what I said? Because I would say that intuition can
No,
be
I'm trying to explain my quote to you that you botched.
Okay. Well,
I have nothing against consciousness.
So
some of my best friends study consciousness. Christoph Koch is a good friend of mine. But what I'm saying is that it's just the tip of the iceberg, and if you ignore the rest of what's happening in the brain, I think you're doomed to going down the wrong road.
Susan Neiman, do you actually still have a point on this? Yeah, you
well,
do.
I had terrible trouble understanding what was being claimed, actually, and I'm very glad that a physicist also found it problematic, because I have no background in physics, I have no background in neurobiology, but I do know something about Plato, for example, and I sort of understand what it means to say that certain values are embedded in a Platonic universe. I don't know what it means to say that, what was it, Kabbalic wisdom is in string theory?
Well, my point there was that many, many cultures have something. Native Americans have this, Hindus have this, Buddhists, everybody has something like this.
Well, something like what, though? I mean, I
like
felt a little...
Platonic information embedded in the Planck scale, something that could be explained by that.
Look, I felt a little bit like Richard Dawkins talking about religion, that is, and saying, if we have perfectly straightforward explanations of this, why do we need to appeal to religion? I felt like appealing just to the religion and the philosophy, because I didn't see what work the science was doing. So what would it mean to say, I mean, I have an idea of let's go back to Plato, I have an idea of justice, right? And let's say that I believe everybody's born with that. I mean, in a Kantian understanding of what Plato was doing, I actually do believe that. Now, you're telling me that somehow the universe has what exactly that corresponds to my idea of justice?
I can answer it for mathematical truth, which is what Roger raised in the first place in 1989. He said the mathematical truths, Platonic values, exist not just in an abstract realm, but physically in the structure of the universe. And then later, ethical and aesthetic values were added in, as well as the precursors of consciousness.
What does it mean for them to exist in the structure of the universe?
Well,
I mean,
everything
they're
exists
mirrored,
in the structure of the
they're
universe.
like... Pardon?
Well, everything exists there. Matter comes out of that. Energy comes out of that. If you have a quantum superposition that collapses due to its own self-collapse, Rogers objective reduction, that's defined as consciousness. So we have a definition or an explanation of consciousness that has ontological distinction. If that happens, it's conscious. It's not just, you get enough computation, consciousness emerges, which is what the neurocomputationalists say. So we're giving it an ontological distinction. If this particular type of collapse that Roger proposed exists, that's a conscious moment. It can happen to an electron, but it takes 10 million years. I don't have time to go into the details, but it's all in the papers on my website.
Andrea,
First, I just want to say that, contrary to what was suggested earlier, we do seem to be...
Could you just...
Oh, sorry, I'm Andrea Hossenstaub. I'm a postdoc. I'm a neurophysiologist. So we do seem to be exploring some fairly far-flung regions of hypothesis space today. It seems to me that what you said is that gap junctions are required for the generation of the gamma oscillation, and that the gamma oscillation is the neural correlate of consciousness. So if this is what you're saying, then it's extremely easy to test, and in fact, this test has been performed hundreds, thousands of times every day. The test that you would perform is to administer a drug other than an anesthetic that also has the side effect of blocking gap junctions, and look at the effect of administering this drug on consciousness. Well, the drugs that they use for prophylactics against malaria, the quinine and quinine derivatives, are extremely potent gap junction blockers. They get into the CNS, and they have dozens of kind of horrible effects on people's psychology, ranging from delusions to outright psychosis, but they do not coincide with loss of consciousness. Is this consistent with your theory?
First of all, there's at least, can I answer? First of all, there's at least 10 different connexins. So a drug may bind one type of gap junction, not another. There's a knockout mouse model that knocks out connexin 43, and those mice they're very messed up, but we don't know if they're conscious. They behave, they survive. But again, there's 10 connexins and another group called panexins, and it's unclear whether any lesion or any drug affects all of them. So what you said doesn't invalidate what I said.
It's true that the connexins, that there are dozens of them, but there's, for the most part, with one or two exceptions, only one is expressed in neurons. That's connexin 36, which is blocked by quinine.
Connexin 43 plus a bunch of panexins. I reviewed this not too long ago.
Okay, this is getting a little bit sophisticated for me.
I'm Saurav Ghosh. I'm a postdoc here at Salk, and my question is basically an extension of what she was saying.
Oh, well, are you sure that's not going to get even more sophisticated then?
Do you think Drosophila is conscious? Because they have gap junctions.
Because they what?
Drosophila. They have gap junctions.
Yeah,
made of
well, that's a good
nexins.
question. You know, at what level of evolution does consciousness appear? And in the model we have, consciousness is defined by E equals h over t. E is the gravitational self-energy of the system. H is Planck's constant over time. So if you set time equal to 25 milliseconds, you need about 100,000 neurons worth of microtubules in superposition. So if an electron were in superposition, it could, and isolated, it would have a conscious moment, but only after 10 million years. So it's a trade-off in evolution in terms of a system large enough to provide, to reach threshold quickly to be useful, but also to avoid decoherence, because the other problem is you have to be isolated. And dendrites in particular are very well suited to avoid decoherence because there's actin gel around the microtubules, and they have the gap junctions and so forth. So I have a paper where I did consciousness cause the Cambrian evolutionary explosion? Because when I calculated out the level at which the system gets large enough to reach threshold in a reasonable time, like a couple hundred milliseconds, is about at 300 neurons. And if you look at the Cambrian evolutionary explosion, small worms and urchins that appeared at the very beginning of the Cambrian explosion were about that size. So I would say the cutoff probably is roughly at that level of 300 neurons.
Okay,
And I don't know if neurocomputationalists can even hazard a guess, because there's no testable prediction, there's no threshold even suggested from neurocomputation for consciousness.
Okay, I think we need to move on to Ramachandran at this point. Thank you, Stuart.
You're welcome. Let me just say I have to run off. It's been a pleasure being here, and I'm sorry I couldn't be around for the rest.
I wish Ralph Greenspan were in the room, since he talks to Drosophila on a daily basis, but I don't see him. So.
Sure.
Well, I'm delighted to be here as part of the Science Network, and I'd like to thank Terry and Roger for organizing this. It's been a wonderful meeting so far, and I've enjoyed many of the discussions this morning and earlier this afternoon. I enjoyed some of Richard Dawkins' comment, and also a lecture given by Neil, which I enjoyed immensely, but there's one minor point of disagreement. I think he got something factually incorrect. And that is, he talked about the glories of the Arab civilization, about Baghdad, which I agree with wholeheartedly. But then he referred to Arabic numerals, that they invented the number system as we know it with 0 and numbers. In fact, these should be called Indian numerals. They actually originated in India in the 2nd century AD and then were transmitted to the Arabs and from there to the West, and Western scholars therefore refer to it as Arabic numerals. But that doesn't contradict the spirit of what you're saying, which I agree with. Now, regarding God, which is the main theme of this conference, I think the word is used in many different ways. On the one hand, there's the idea of a very abstract sense of, that many of us scientists have, of the sense of wonder we experience when contemplating the cosmos. In other words, God is synonymous with natural phenomena, with the universe, if you like. And this is a recurring theme in many Eastern philosophical traditions. And I can't find anything wrong with that, and I think many of you would agree. But then there's a notion of a personal God, that there's this guy, old man, watching us, and who punishes us for our sins and rewards us, gives us brownie points for good deeds. And that I find hard to believe, and I'm sure that most of you here would agree with that. Now, I also want to talk about, what I'm going to mainly talk about is the origin of religious belief. What parts of the brain are involved. Obviously, the brain is involved in religious belief, but are some parts of the brain more involved than other parts? And also the evolutionary origins of religious belief. And let me say at the outset, I don't believe in intelligent design. I believe, maybe I'm preaching to the choir here, but essentially a random process of natural selection is what's involved in evolution. And I don't believe in intelligent design. And it's ironic that our president is championing this view of intelligent design, given that his own existence is a living negation of any such principle. Now, the other topic that came up repeatedly is the notion of consistency of belief. How can somebody be an eminent physicist, even logician like Kurt Gödel, come to believe in something like God? So how can somebody hold inconsistent beliefs, even though the person may be extraordinarily intelligent? And I have an answer to that. I think that consistency of belief, in fact, is the exception rather than the rule in human behavior. We have all these parallel brain mechanisms, modules, which are performing different computations, and they're approximately in coherence. And that's important, producing coherent behavior, important for survival, and that's why there's coherence. But sometimes they're out of sync, and that's why you get inconsistencies in belief systems. I'm reminded of Niels Bohr, who had a horseshoe on his door, and somebody asked him, "My God, how can you possibly have a horseshoe? You don't believe that it brings good luck?" And he said, "Well, I don't believe in it, but it works anyway." Okay. Now, the most flagrant,
He said it works even if you don't believe
if you okay. Now, the most flagrant example of this is seen in neurology. And we've been studying patients with a disorder called anosognosia, where a patient has a right parietal damage, stroke affecting the left side of the body, complete paralysis of the left side of the body, including the left arm. This person is quite intelligent, engages in a conversation about politics, can play chess with you, and so on and so forth. But then you say, "What about your arm? Does your left arm work?" And the patient says, "Oh, it's fine. It works fine." Right? So here's a patient who's completely intelligent, denying something perfectly obvious, like the left arm being completely paralyzed. In extreme cases, you show his left arm to him or her and say, "What is this?" He says, "Oh, it's my mother's hand," or "It's my father's hand." And you say, "Well, why do you think it's your father's hand?" He says, "Well, it's big and hairy, so it must be my father's hand." So here's somebody who is perfectly lucid and intelligent, holding this absurd belief that their left arm is not paralyzed or belongs to somebody else. In fact, I saw a patient the other day, and she said, "My left arm, this arm doesn't belong to me. It's not paralyzed, it's fine." Okay. Then I said, "Touch your left shoulder with your right hand." And of course, there's no problem. The right hand is fine, and he does that. Then I said, "Touch your right shoulder with your left hand." And he does this. Now, that's amazing, because it shows that somebody in there knows she's paralyzed. Okay? This is an absolutely striking example of inconsistency in belief. Now, you may think this person denying paralysis or denial is a very rare neurological syndrome, but not all of us here. But in fact, it's extraordinarily common. All of you here, most of you here, engage in denial all the time. But let me give you a little proof of this. Somebody recently conducted a survey asking people, everybody, are you above average or below average in intelligence? 98% of people say they are above average in intelligence. And this is mathematically impossible because it's obviously a Gaussian curve. And what it shows is half of mankind is in denial about its stupidity. This was painfully evident in our last presidential election, by the way. Okay, so now let's get to the neurology. And one group of patients we have studied is split brain patients or commissurotomy patients. These are people whose corpus callosum has been cut, and anterior commissure and massa intermedia whenever encountered. So essentially you're doing a karate chop right through the head and creating two human beings in one body, in one skull, two spheres of consciousness. Now, many experiments have been done on these people, and I asked myself a very simple question. Okay, you've created two people here. What about their personalities? Do they have different personalities? What about their aesthetic preferences? Does one like blondes and the other like brunettes, for example? One like chocolate and the other like vanilla? What happens? So we tried these experiments, and what we did was we had to first train the right hemisphere to communicate with us. In fact, the right hemisphere can read simple commands, simple words, simple sentences, and then you ask a question and say, point to a box, yes, no, I don't know, because it can't talk. The right hemisphere cannot talk, but it can comprehend simple semantics, simple questions. Left hemisphere, of course, can talk, so you can present boxes, yes, no, I don't know. So we asked, for example, are you at Caltech? And the right hemisphere pointed to yes. Are you on the moon? It said no. Are you in California? It said yes. Are you asleep? It said no. Then I said, are you a woman? And the patient was male. And he pointed to yes. And then started chuckling and laughing. So at least the right hemisphere has a sense of humor. Okay. Okay, so now comes the big question. What if you ask, do you believe in God? So I said, do you believe in God? And the right hemisphere went straight to yes. Right? Asked the same question to the left hemisphere, yes, no, I don't know. It went to no. Right? So here's a human being whose right hemisphere is an atheist, and left hemisphere, on the other hand, believes in God. And this finding should have sent a tsunami through the theological community, but barely produced a ripple, because it raises all kinds of profound theological questions. If this person dies, what happens? Does one hemisphere go to heaven and the other go to hell? I don't know the answer to that. Now the next group of patients we studied were patients with temporal lobe epilepsy. And it's been known for a long time, people with seizures originating in the temporal lobes, epileptic seizures. Normally you think of epileptic seizures as being a grand mal seizure, and you have a seizure involving the whole body, you stop breathing, you utter a loud cry, and you fall down. But in fact, there's a group of seizures, a kind of seizure called temporal lobe seizure, or psychomotor seizure, which is purely a mental seizure, an emotional seizure, which doesn't necessarily involve a bodily seizure. And what's astonishing, there are many symptoms of this, emotional upheavals and extraordinarily emotionally loaded experiences, a turmoil of emotions that the patient experiences. But the most striking aspect of these people is not only during the seizures, but interictally, when they're not having seizures, they have tremendous religious experiences and mystical experiences. They say things like, during the seizure, I experience God. I see the meaning of the universe, the true meaning of the universe, for the first time in my life. Everything is deeply significant. I understand my place in the cosmic scheme of things. That's what they say. And this happens also in between seizures, but primarily during seizures. Sometimes they'll actually say, I'm talking to God, or God is talking to me. Now, why does this happen? Well, there's 4 or 5 hypotheses. One hypothesis is maybe God is visiting and coming to see them. And you can't discount this on the basis of any scientific evidence. Although I would say, saying that God works in very strange ways. But I find it strange that she would manifest herself in temporal lobe seizures, only in epileptics. But, we don't know. Okay? So, first of all, the idea that God visits you, and I can't disprove that. The second idea is they're just mad. They're just nuts. They're crazy. Something is going on in the temporal lobes. They become crazy, and they believe in God or believe in something. Well, that doesn't work because I've seen other crazy people who are schizophrenia, who really are crazy, and majority of them don't necessarily believe in God or become religious. Some of them do. They'll say, I'm Napoleon, or I'm God, or I'm George Bush, or whatever. Okay? But majority of them don't necessarily believe in God. But in temporal lobe seizures, a substantial proportion, maybe 30 to 40%, have this intense religious fervor and belief in God. The third hypothesis is that maybe there is this cauldron, given that it's limbic system where the seizures originate, and the limbic system is very much involved in emotions. There is this cauldron of emotions, this emotional turmoil in your mind, and then the left hemisphere kicks in. In the left hemisphere, we know from a number of experiments on split brain patients and indeed on stroke patients, is involved in confabulation. If something doesn't fit, doesn't make any sense, the left hemisphere tries to spin a yarn to try to make things more consistent. So maybe when there is some strange, something bizarre going on in your mind, which is otherwise inexplicable, the left hemisphere starts confabulating and saying, the only way I can make sense of this is there is a visitation from another dimension, i.e. maybe it's God is visiting me. Okay, in other words, God is the ultimate confabulation by the left hemisphere. Okay. Now another hypothesis is, now I can't rule that out, that's a possibility. Another hypothesis is kindling. That is, when any one of you look at the world, you look at objects around you, look at people, what happens, the messages cascade from the retina into the visual areas of the brain, visual cortex, and about 20 or 30 visual areas in the brain, and you compute the statistics of the world, you look at features, you analyze the features, finally you recognize objects, and objects then produce the appropriate emotional experience. In other words, the amygdala, which is the gateway to the limbic system, performs an emotional surveillance and looks for emotional significance. If something like a predator or a prey or the dean or something very salient like that, your emotional, or something sexual, you get emotionally aroused and you start sweating and your heart starts beating faster because of autonomic arousal that takes place, and you're preparing the body for feeding, fleeing, fighting, or sexual behavior, as the saying goes, okay? So all of this takes place instantaneously, very, very quickly, and maybe what's happened to these patients is because of the repeated volleys of temporal lobe seizures, some of these connections have been indiscriminately enhanced. And when that happens, everything becomes deeply significant and salient. So normally when I look at this, you know, if I look at a pinup or I look at a lion, I get aroused. But I look at this, I don't get aroused by a bottle of water. But these people, because of the kindling, everything and anything they look at is deeply significant. And they see infinity in a grain of sand or whatever. And they see everything they look at is deeply profound and deeply significant. And this is akin to what many religious mystics talk about, seeing deep significance in everything in the cosmos. Now, how do you test that idea? Well, we said, okay, let's measure their sweating. You can do this with a galvanic skin response, where the sweating changes. When you look at something significant, you look at a lion or a tiger, or you look at something sexually provocative, then you get a huge galvanic skin response. If you look at a table or a chair, your galvanic skin response is flat. You don't react. What happens in a temporal lobe epileptic? We said, well, if this hypothesis is correct, anything and everything should produce a big jolt in the galvanic skin response. So we did this experiment. We showed them, of course, lions and tigers, they get a big galvanic skin response, or a pin-up, they get a big, oh, I take that back. Lions and tigers, violent scenes, horrible scenes, they get a big galvanic skin response. But we show them things which are utterly trivial, like bottles of water, or a shoe, or a pen, or something. Nothing happens, as in a normal person. In other words, the theory that this is just kindling and everything is deeply significant is disproved. In fact, when they look at sexually provocative images, they don't get a galvanic skin response, unlike most normal people, right? And this is consistent with the fact they actually have hyposexuality. Their libido is reduced in temporal lobe epilepsy. But now comes the important finding. When we showed them religious icons, like a Star of David, a cross, or a word God, or the word Mary, the word Jesus, there's a big jolt on the galvanic skin response. Showing, and what we said in this abstract at Society for Neuroscience about, 8, 9 years ago now, that something is going on in the temporal lobes, in temporal lobe epilepsy, and maybe in all of our temporal lobes. There's a group of neurons which is firing in abnormal manner, which makes you more prone to religious belief, okay, believing in a deity or in God or whatever. And these neurons are hyperactive in these people, hence the propensity to religious belief. That's all we said. In fact, at the end of the abstract, the last line was, this does not prove there's a God module in the brain. But the press got hold of this and went crazy and said, Ramachandran has discovered the God center in the brain. And in fact, the Bishop of Oxford was questioned about this. And he said, well, so what? It just shows that when God made us, he put an antenna in all our brains, and it just happens to be in the temporal lobes. Fine, okay? So anyway, and for some time in the internet, there was a talk about a G spot in the brain. Okay? All right, so now the question then is, why do you have this neural circuitry in your brain whose activity gives rise to religious belief? Finally, there are two possibilities. One is it's a spondrel. In other words, it's doing something else in the brain which has evolutionary benefit. I don't know what that might be, right? Belief in maybe, I don't know, I don't want to even speculate. The other possibility is it was in fact selected for by natural selection because in fact, look at every religion, every society, every tribe in the world, they have some kind of religious belief. And this rituals, the belief in a hierarchy, the ritual chanting, the mantras, the dances, all of that confers a certain stability and order on society, and maybe that's what provided the selection pressure for the emergence of religious belief and God. Finally, let me conclude by saying none of this has any bearing on whether God really exists or not. As I said before, this is all about how religious belief originates in the brain, and that's all I have to say. Thank you.
So, do you have any, there will be some questions, and obviously Richard wants to ask them, could you just comment very quickly on the recent Time magazine or the book by Dean Hamer where he talks about God in the brain, the whole notion of that?
I'm afraid I haven't read it. So
okay. All right, so we'll come back to that later then. Richard, do you want to?
Just a simple factual question.
Well,
a simple factual question. The temporal lobe epilepsy people showed a strong galvanic skin response with religious icons. You didn't say, I think, whether normal people do.
Yes, that's a very good question. When we look at normal people, well, I don't mean normal religious versus normal atheists, okay? There is that question. But when you look at normal, just anybody, you find, in fact, a high response to violence and a high response to, especially high to sexual, but not very much to religious icons. In fact, you can even look at religious people, and you don't get that much of an enhancement in religious response compared to temporal lobe epileptics.
So Charles Harper, could you introduce yourself, please?
Charles Harper, John Templeton Foundation. Rama, I love your talks. I want to challenge you on something that you jumped over very early on. You made a claim that it seemed obvious to you that you couldn't have a person who was scientific and also believed in God, that it was inconsistent. And
Only the personal, yeah, go on.
Personal view of God. Okay, I want to challenge you on that. What actually from science, not from a kind of culture of science or philosophy of science or from scientism, but what actually from scientific research results would you cite to support that view?
Well, I mean, this goes back to the notion of agnosticism, and somebody raised the point about teacups. I think that if I were to say there is a dragon with spotted, pink dragon with green spots, floating out there billions of miles away, and you say, I'm agnostic about it, I don't know. I mean, the notion of a personal God has that same status, I think. Now, if you're talking about an impersonal, abstract God, like in Hindu philosophy, where they talk about Brahman, which is synonymous with the mystery of existence, as Bertrand Russell said, that the fact that something exists rather than nothing is itself the greatest mystery of all. From that point of view, I am agnostic. But from the point of view of somebody watching you, yeah, I mean, everything we know in science, Occam's razor, why would you want to postulate such an instance that Laplace said, or indeed Newton said when he said the hypothesis non fingo, right? Why would you want to postulate something like a personal God when there's nothing that demands the existence of something like that?
I would just still challenge you that what specific scientific result, not a philosophy based on an idea of science or a culture, but what specific result publishable in research literature, that is where there's data and measurements, what actual scientific result would you use to justify such a denial of potential compatibility? Because as you said, there are many scientists who live, very distinguished, undistinguished, all sorts of scientists, who live with a compatibility of these beliefs, including the impersonal and the personal God. And it is not the case that most distinguished scientists find that there is a powerful necessity based on their scientific experience or commitments or career to make a choice. There are ideological pressures which have to do with scientism, with culture, and so forth,
Well,
which
I mean, let
do
me just
require that. But science itself, I would challenge you to find a true scientific result that is an actual measurement involving real data that would require such a decision to be made by a scientific person.
Well, just to play devil's advocate here, I mean, you could say the same argument about ghosts. You could say that there is a ghost right now here which no scientist can ever disprove. It doesn't do anything, it doesn't interfere with the events in the world, but no scientific measurement of any kind can disprove the notion that there is a ghost sitting here, right? And I submit that that's equivalent to your remark. I mean, I agree with the spirit of what you're saying, but equally no scientist can ever disprove that. And maybe there are others in the audience who can chime in, like Richard Dawkins.
Can we just do Larry Smarr first, and then Sam Harris, and then come back over there, if that's okay.
So I was fascinated with your...
Could you introduce yourself?
Yeah, Larry Smarr. I'm a professor at UC San Diego in computer science. With this universal human need to create a God emotion, a God sense, and we found that a lot of external drugs, for instance, when they're ingested, the reason that they get selected for those particular drugs is there are endoreceptors that provide some sort of change in the brain function that is pleasurable or is, something that people desire to do. So it seems from what you're just mentioning there that there may well be a component of the brain which universally people have found how to stimulate through trances, meditation, whirling, a zillion different chants and rituals. What kind of research has been done on trying to understand if there is, in fact, a very human part of the brain that if stimulated, seems to be very meaningful or pleasurable to people?
Well, I mean, if you're talking about certain neural structures in the brain, whether they have evolved through natural selection or they're byproducts of some other process, they may be neurotransmitters which are specific to those systems. And in fact, my former colleague, Francis Crick, used to call them theotoxins. And that is going a little bit too far, but they may in fact be transmitters. But there's a colleague of mine, John Smithies, who works on this very topic. Is he here? Yeah, there's John. I mean, he's interested in the pharmacology of transcendental states and religious beliefs. And maybe he would like to comment on this.
John Smithies, right. Here we go.
Yes, I've been involved in work with mescaline for many years. And I think many of you know that hallucinogenic drug which Aldous Huxley made very famous in his book, The Doors of Perception. And there are other drugs which also have powerful effects on this kind of psychology, cocaine, some anesthetics, and so on. But I'd like just to discuss how mescaline works. And these hallucinogenic drugs have a very specific action in two ways. Number one, they produce fantastic visual hallucinations. And these are described by the people that have them, who've been very down-to-earth scientists, most of them, Havelock Ellis and Ware Mitchell and MacDonald Critchley, very well-known neurologists, as being more beautiful than anything that they've ever seen in normal art. They are experiences of art, extremely powerful in all respects of color and shape and so on, what makes art. And so also, some of these people have the kind of experience that Rama was describing, of sort of union with God, these mystical experiences, and so on. And these all act on the serotonin 2A receptors. There's a specific receptor in the brain which all of these act on. And some of them are derivatives of adrenaline, like mescaline, and some are derivatives of serotonin, like LSD, dimethyltryptamine, and so on. But they all act at one particular place, the 2A receptors of serotonin. Now, serotonin is the earliest transmitter in the brain. It's the first one that forms. It's extremely primitive. Serotonin has a very important role in plants and so on, has extremely complicated role in the brain. And the cell bodies are all in one little place, the Raphi nucleus, and the axons go all over the brain. And the so there are but the highest proportion of receptors are in the cortex. It's a cortical thing, and some of these, the 2A receptors are stimulatory, and the 1A are inhibitory. So what these people are having is a gross overstimulation in the cortex of their 2A receptors, which induces these powerful visual experiences, powerful religious experiences, but very interestingly, they don't have any music. They never hear great music. They see this wonderful art, these wonderful pictures, but they never hear any music. So, but although the temporal lobe has just as many 2A receptors as the occipital lobe, so that's a very interesting problem. Why is that so? The 1A receptors, the inhibitory ones, there's one study done using imaging techniques, just recently published, of people who were two people, one group of people who were not psychologically interested in religion, the other ones who were. And they measured the activation of the 1A receptors on binding using methods of imaging methods. And they showed that the people who were religiously inclined had a decreased binding, very significant decreased binding to the 1A receptors. So the 1A receptors were not working. And they're the ones that inhibit the activated ones by the LSD. So the two lines of evidence, the 2A receptors are activated by drugs that produce religious experiences, and the people who have them normally have an underactive system which inhibits it. So the 2A receptors are, for some reason, very difficult to explain. Why should they produce in brains of people who can't themselves produce any great works of art? Nevertheless, anybody who takes these things will have these fantastic experiences which Aldous Huxley describes so well in his book. And of course, the serotonin is not the only receptor. There are opiate receptors in the brain which cause similar experiences. There are the many other ones as well. And particularly when we're talking about certainty, this certainty has come up many, many times in this meeting. What does cocaine do? Cocaine releases floods of dopamine in the brain. Dopamine is the transmitter which signals reinforcement, and the effect of cocaine is to produce complete certainty. The rush of cocaine produces tremendously clear mental feeling, utter certainty, you've solved all the problems of the universe. And of course there's one other one which solves the problems of the universe, is laughing gas. Nitrous oxide, to go back to the anesthetic we heard earlier. And I think it was Oliver Wendell Holmes who had a reaction of laughing gas. And when he woke up, he said, I've solved the problem of the universe. There's a smell of onions all around it. And that's the kind of level that most of them are.
Paul.
So we talked earlier about, just a second round, we talked earlier about whether we could evolve a new language for describing all this stuff, whether poetry, I mean, but the question is whether people are willing to walk around saying, I'm having a dopamine rush, or I'm having an excess of oxytocin right now, or I'm having an excess of 2A receptors. It somehow lacks the poetry. But of course, Pat, you would disagree, right?
It's Pat Churchland. Rama, I wonder if you could say a little bit about the transcranial stimulation studies of temporal lobe on normal subjects and the feelings that produces.
Yeah. I'm afraid I haven't looked at the evidence very carefully, and I've known people who have been in this gizmo, and results are ambiguous. As you know, there was a recent study from, I think it was from UCLA, showing that if you stimulate different parts of the parietal lobes, you get out-of-the-body experiences. Either the sense of you being up there in the ceiling and watching your own body, like a disembodied soul, watching your own body, or sometimes, and I've seen these patients with right parietal lobe disturbance, who feel that they're here, but they feel another presence of something which they can't describe. And sometimes they interpret it as a supernatural thing behind them, watching them. So either they get disembodied, watch their own bodies, or they're here. So all of these paradoxes arise because you construct your body image in your parietal lobe. You get all these interesting paradoxes. And it's easy to misinterpret that as some sort of religious experience, or God is looking at me from the shoulder, or I'm looking at my soul is up there in the ceiling looking at me, and that sort of thing. And you can probably get that with transcranial magnetic stimulation, although the results have been extremely variable. And I think actually Richard was a subject in this. Maybe he could illuminate.
Richard had a question as well, I think, and then Harry Croto.
I was a subject in Michael Persinger's apparatus. I'm afraid I was a failure. It did absolutely nothing for me at all. I'm apparently not, to my great regret, I was not susceptible to any kind of mystical oneness with the universe.
Do you have a question from
Paul.
earlier, or has we answered that? Okay, so Harry.
Yeah, I have a
Could you introduce yourself?
statement, Harry Croto. I actually interviewed Charlie Towns, a person for whom I have great admiration as a scientist, probably the best, one of the great physics Nobel Prizes of the century, of last century. And I questioned him about, I've interviewed quite a lot of Nobel Prize winners, and we've discussed religious issues. And it's quite interesting. I said, how does he respond to the question that Einstein was posed to Einstein, was, do you believe in God? And he said, I believe in the God of Spinoza, who reveals himself through the harmony of what exists, not in a God who concerns himself with the fates and actions of human beings. And he said, during the interview at least, that he felt he was somewhere at that point. And that's a very different sort of God. I think it's an interesting point to take. I did, however, I must admit, send an email not that long ago to Charlie to push it that a little bit further, because I felt it was an interesting point. Because here was someone who, as far as I'm concerned, was able to have a schizophrenic attitude. In one case, a fantastic development of the maser and the laser. Also, in my own area of microwave spectroscopy, writing a fantastic book, was unbelievable rational analysis, and yet something so far apart from me with regard to religion. And he said, but he was somewhat equivocal at the second stage. But I felt that in discussion he had a problem, the problem that many religious people who are scientists have. And so it's not as cut and dried. And of course, many of you will know that Charlie Towns won the Templeton Prize last year. I mean, this year it was Barrow, but I think it's interesting that certainly this, arguably the greatest trophy of the Templeton Prize, had a little bit of problem when I questioned him how he sort of saw Einstein's somewhat deistic attitude of religion.
Thank you. Paul? Philip?
So I was wondering if the temporal epilepsy patients were also showing abnormal activity when forced with ethical choices, for example. And generally, what the discussion we're having today tells us about ethics rather than just religion.
That's a very good question. I think Pat might have some ideas about this, but the general question is what, people might think I'm being very neuroreductionist and this might eliminate human values. Far from that. In fact, there's a recent discovery, which I'll tell you about, which we have been studying, but originally discovered by Giacomo Rizzolatti. These are groups of neurons which are called mirror neurons. Some of you may already know about this. If you record from the front of the brain, from the frontal lobes, there's a group of neurons which will fire when the monkey, or indeed the human being, reaches for a cup, reaches for a peanut, pulls a lever, pushes something, different neurons for different actions, semi-skilled actions. This has been known for 20 or 30 years from Vernon Mountcastle. But what people have now found is there's a group of these neurons, a subset of them, will fire not only when the monkey reaches for a peanut, but when the monkey watches another monkey reach for a peanut. So it's as though people call it monkey see, monkey do neurons. And what's interesting about them is it's as though they're putting themselves in the other monkey's shoes, doing a sort of a virtual reality simulation in their brains. And that's why they're called mirror neurons. And the relevance to your question is, now people have found in humans, if you record from the anterior cingulate, it's been known for a long time, if you record from the anterior cingulate, if you poke somebody with a needle, the neuron will fire. So people used to say it's a pain center and there's a pain neuron. But in fact, many of these neurons will fire when you poke somebody else with a needle. So it's sort of like an empathy neuron. And what's amazing about this is this neuron is actually dissolving the barrier between you and other people, between self and others, not in some metaphorical sense. If you look at Eastern mystical traditions, they talk about dissolving barriers and becoming one with other people, but literally dissolving the barrier, because those neurons simply don't know the difference between poking you and poking the person. Okay? So in fact, it provides a basis, almost a neural basis, for ethics. And I don't want to commit the naturalistic fallacy here, but it provides a neural basis for ethics, a strong neural basis for ethics. I like to call them Dalai Lama neurons.
After you're through. Do you answer?
Beth.
Elizabeth Loftus. Now, why would you assume that that's an empathy neuron when maybe what these people are doing is just imagining it happening to them? And it's a selfish thing.
Yeah. There is a circularity there. What I'm arguing is that the neurons, the whole notion of you and other, in other words, even self, okay, your notion of yourself emerges partly from the activity of these neurons, because part of what you regard as yourself is looking at yourself as a social being as other people look at you. And partly it's these neurons that allow you to do that, to look at your own self from the point of view of another person. So there's a little bit of circularity in your question. And in fact, recently we have shown autistic children, some autistic children, many of them, lack mirror neurons. They have mirror neuron dysfunction, which is one reason they lack empathy and lack a theory of other minds and are unable to put themselves in your shoes to look at the world from your point of view.
Carolyn?
It's not been studied. It's a very reasonable hypothesis that they also have some dysfunction in the mirror neuron system. By the way, there's now a mirror neuron mania, but we've got to be careful not to attribute everything to mirror neurons. But I do think they're doing some very important things and may help answer some of the most enigmatic aspects, elusive aspects of human nature, which have proved very difficult to tackle.
Joan?
Hi, Rama. Joan Roughgarden here. We were on a panel
Yes.
together yesterday, and I personally find these facts very interesting. But I am puzzled, frankly, as to why you think they're important or relevant to the issue at hand about say, theology or the connection with the compatibility of religion and science. And there are 2 points that I would like you to address, if you might. The first is, of course, that for any mental state, there will be a corresponding physical state. And so there would undoubtedly be a brain state before and after eating chocolate, before or after eating anything else, anchovies, or before or after seeing a movie. And so one interpretation of your findings is that you simply have very accurate gadgets which detect the brain state corresponding to a certain suite of mental states, namely those associated with.
Yeah.
Now, there would also be, with some other gadgets, presumably mental states corresponding to the scientific experience, like that moment of really great linear thinking where you come up with an answer or something. So that's the first thing, is why aren't there just simply zillions of different mental states and you just simply have a bunch of them right now, and that it's just an interesting curiosity that you found these. Now the second point with respect to
have him answer the first one first?
Yeah, let me answer the first one first.
Oh, okay. The second one's derived.
You see, it's true that for every thing you see or perceive or think, there's some corresponding brain state.
Yeah.
But that's precisely what I'm interested in. As a neuroscientist, I want to know which. It's not merely that there is a brain state. Everybody knows that. But which particular areas of the brain are involved? What is the circuitry involved? How did it evolve? What is the biology? It's the same as any other biological system. When you consume food, obviously it comes out and you absorb nutrients. You could say, well, why do you need to know how it's done? I want to know how fats are absorbed. I want to know how glucose is absorbed, what enzymes are involved, what part of the liver is involved. These are fascinating, detailed questions we would like to address.
Okay.
Now, regarding the other question, does this in any way negate a sort of very abstract conception of a God, the Spinoza God, or what we call Brahman in Hindu philosophy? I would say, no, it doesn't negate that. That also answers Chuck Harper's question. And in fact, you could say that sense of awe that many of us scientists have about the very existence of the cosmos, human existence, all of that, if you want to call that God, I mean, I would go along with that. So in a sense, what I'm talking about is religious experience, parts of the brain involved. But it's different from, it's sort of not correct to compare it with saying chocolate, right? Because I am interested in what happens when you eat chocolate. But there's different centers in the brain. And they're called centers concerned with appetite, with regulation of body weight, and why chocolate rather than something else. These are all scientific, biological questions, and equally legitimate, why do you have religious experiences?
Yeah, well then, the follow-on to that, which is the second question, which is presumably there are different parts of the brain in which one does have a scientific experience, and you've not shown that there is any physical incompatibility between the parts of the brain that turn on when you have a religious experience from a part of the brain which would turn on if you had a scientific experience, so to speak. And so even your own data would be consistent with a compatibility of science, of a scientific experience along with a religious experience.
Well, again, it harks back to whether you're talking about religious experience in a very abstract, mystical sense of, some cosmic God, versus supposing I see an angel, or I don't want to mention a particular God for fear of offending people, but a particular God right in front of me. If I see a glass there, and I can go find a neural basis for that, and I explain how you see it on all of that. But if I say I'm seeing an angel, I can prove by independent physical means and measurements there is no other thing there. There's only your brain activity, right? So in one case, you can make a correlation, and a systematic, lawful correlation, between the events in the external world, which are independently measurable, and measurable brain events. In the second case, there is nothing in the world that is independently measurable, which you're correlating with your brain events. That's the key difference between a hallucination and a delusion on the one hand, and the real correlate of a real object being perceived by the brain on the other hand. But again, let me say, this doesn't negate the value of a religious experience to the person who's experiencing it, or the notion of some cosmic God, which is not somebody watching me and punishing me. So maybe there is that sort of...
Now, Bill Hurlbut has a question, but let me just interject one thing, which is there was an experiment done about a year ago by Naomi Eisenberger and Matt Lieberman at UCLA, in which they had somebody in an fMRI scanner, and they were involved, they thought they were a part of a group of people playing a game. And you could see in the scanner, you could see an object being thrown to what you were told were other players in the game. And at some point during the game, the person in the scanner was actually excluded from being able to play the game. So they suddenly found themselves watching other people playing a game, throwing a ball, computer ball. And at that point, the person's, according to the fMRI scan anyway, the person's brain started registering in what would be called pain areas. In other words, the areas in which they would have lit up when they were experiencing actual physical pain were activated because of this moment of ostracism, or if you want to call it, shunning. So I think these techniques can be extraordinarily valuable in beginning to learn about what's going on in some of these situations where these social situations that involve hostilities and shunning and so on. Bill, can I get this to you?
Well, I'd like to ask a funny
William
question
Hurlbut.
here, and I don't do this in a spirit.
Could you identify yourself as well, please?
Pardon me?
Could you identify
I'm Bill Hurlbut from Stanford. Professor Dawkins mentioned that he did not respond to the stimulation. This was the out-of-body experience stimulation. Is that what you're referring to? Pittman study, is that what you said?
Michael Persinger puts
Persinger. And that evokes the out-of-body experience in some people?
It's supposed to mimic the effects of temporal lobe epilepsy, and in about 80% of subjects. It's supposed to mimic the effects of temporal lobe epilepsy, yeah. And in about 80% of subjects they get mystical or religious experiences depending upon the particular religion in which they've been brought up. So if they're Catholics, they see Virgin Marys and if they're Muslims, they see I don't know what and so on. I saw nothing and felt nothing. There was a control, which was a vicar, who was done at the same time. This was for television, and the vicar claimed to see nothing, but his EEG pattern was an absolute champion subject. I mean, as far as Persinger was concerned, looking at his EEG, this vicar was a total susceptible subject. And what Persinger described was that the vicar began by showing all the symptoms of getting the mystical experience, and then suddenly his EEG started filling up with all sorts of extraneous noise. And Persinger's interpretation is that he was afraid of getting mystical experiences, and so he was doing something like reciting multiplication tables or doing something to try to distract himself.
Well, apart from the vicar, and here I ask this in a spirit of inquiry, not challenge, but and this is a very personal question, but have you experienced mescaline or laughing gas? Maybe you don't respond to these.
To my regret, no.
Okay, here's my real question then. And by the way, as a side comment, it strikes me that the out-of-body experience could very well involve some interaction with the mirror neuron systems. Imaging yourself externally and feeling both identity and the external
Yes,
sense.
I think you're right on the target there.
And it also strikes me that the whole notion of a personal God, we may be trivializing what we're talking about here, because young children tend to personalize the world around them, and we may see things through our mirror neurons in a sense that I don't know how to explain this. It's a rather abstract thought, but I think Rama knows what I'm talking about. The children see person a lot more than adults do in the world. You can elaborate on that in a minute, but let me ask you this question, which is really what I started with. So you have an expression, a pathological expression of a manifestation of a religious experience, and you use the rather pejorative word confabulation, because you're assuming it doesn't have any kind of transcendent correlate.
I said it's one of many possibilities. Yes.
Okay, and I know you're not hostile to these notions, but what does strike me as another possibility is that there's a variation in the way the human brain is constructed, and that you might, if you inquired, and I'm asking you if you have inquired and know anything about this, you might find a equivalent atheist module, if you will, and I know you didn't say it was a module, but you know what I mean.
Yeah.
You might find a personal disposition that found the whole notion of God very alien, and that might not be normative in society either. In other words, you might find the atheist equivalent of temporal lobe epilepsy. What do you think?
Well, in fact, I think that's true, because as we earlier heard, majority of people do believe in a personal God. So in fact, there may be a neural circuit predisposition to believe, and the people who are atheists, like many of us here, or agnostic or whatever, are in fact mutants. We don't have the appropriate theotoxins in the brain, and so we were deprived in that sense. Now, again, there's no sort of, I'm not debunking what you're saying. I'm saying, this is a variation in the population. And maybe there's sound evolutionary reasons for empathy, religious belief, and all of that. And maybe some people lack that, and they're called atheists.
Neil?
If I'm to understand some of the incentive of this effort is to reflect on whether one can account, you didn't say this explicitly, but it's deeply implicit in this whole conversation, whether one can account for example, the belief in a personal God as the sole consequence of activity in the brain, rather than as there actually being a personal God that's out there. And getting back to the comment made by the gentleman from the Templeton Foundation.
Charles Harper.
Charles, hi, hello. I think there is, in fact, there are, in fact, tests. You said, is there a shred of scientific evidence that refutes the personal God? I don't want to put words in your mouth, but I think that's the essence of your point. I think there are tests that have been conducted, but they just weren't thought of in the way that you posed the question. For example, most people who would claim a personal God would claim that that God answers prayers. So you can do prayer studies and ask, is what you prayed for under these controlled circumstances responded to in whatever way you had hoped in your prayers? And from my read of prayer studies, they consistently come up negative when they're done in a controlled way. And when people believe they're being responded to, it's because they've removed they only remember the hits and not the misses. But not only that, I think there's an even bigger case here, and it's summarized simply in the images of the pale blue dot. One wouldn't call this a scientific experiment, but it's a scientific sort of plausibility statement. Because as you ascend from the Earth and look at our temporal, spatial, and organizational insignificance in terms of the scale of the cosmos. If you're going to say that the same person who made the cosmos cares about your life on this earth, the bigger we know the cosmos to be, the more of an expression of hubris or ego that represents. And then you end up drifting away from the idea that the person who made the universe cares about your prayers. And so it's a plausibility argument. I wouldn't call it a scientific experiment, but in science you always have to make a judgment as to what is sensible given the information and what is not. And the bigger is the universe, the less sensible a personal God seems. And I just want to get back to the opening remark that, as you said, most people here would not agree to a personal God, even if there was some sensitivity to a God of initial force.
Yeah. Well, it's a good point. And in fact, the most famous example of that experiment of prayer is the one conducted by Francis Galton, who was a cousin of Charles Darwin, who said, well, let's do the simple version of this experiment. Most people in England pray for the king and the queen. You know, God save the king. Long live the king and queen. And then he's found that the average lifespan of the king and queen actually is lower than the general population. So he said this obviously disproves the hypothesis. But on the other hand, the counter-argument to that is many people say, well, they were not being sincere when they prayed, when they said God. So it goes on. You know.
Scott?
Charles has a question. Sorry.
Go ahead, please. No, go ahead.
Yeah.
Sorry.
Charles will come up there in a minute. Okay.
There's one question here, and then...
Let's just go with Scott's question first, and then perhaps you could respond to Neil's.
So everything you say may be right, but you seem to leap from the evidence to conclusions about gods and beliefs and consistency, maybe a little too fast. First, the overwhelming majority of people never have a religious epiphany.
Sorry, never have?
A religious epiphany.
Okay.
Second, the kind of experience, mystical experience you're describing seems also to work with Buddhist monks and has nothing particularly to do with personal God concepts at all.
Oh.
And third, you are describing a part of the brain. So let's take something like luggage in an airport, okay? Luggage is all over the airport. And you're describing it in one particular part, namely standing in line maybe to put your luggage on the counter and get it. And from there, inferring about what might be the nature of luggage.
Well, it's a good question. I mean, I think this is not specifically about religion and God. It's about the whole question of localization of function in the brain. The short answer is I never claimed that there is one little module. That was a misquotation. But there are, in biology, specialization is the rule rather than the exception. I mean, people would have said, well, why do pigs give birth to pigs rather than donkeys? And people would say, well, it's a mystery, it's the entire pig that's involved. But in fact, people homed in on the chromosome, and they found it's in the chromosome. And Morgan showed if you zap it, you get mutations in Drosophila. Then they said it's not the whole chromosome, it's not histones, it's DNA. They homed in on the DNA. Likewise, I claim that different parts of the brain are specialized for different aspects of cognitive mental capacities. But this doesn't necessarily contradict what you're saying.
Charles?
Yes, I'll just respond to Neil. Yeah, I've had some experience with these prayer studies because it's quite common that I'll be involved in reviewing them and advising our trustees, or before that Sir John Templeton, on whether to fund prayer studies. So I spent some time looking at them and thought that null results were actually well justified by the data. Most of the claims of non-null results were spuriously argued. Recently there was this study published by a group at Harvard that we did fund, and I was very happy that it came out with a null result. Now, I think that these kind of scientific tests can persuade people out of what we might call a naive theism, theism being a way of going beyond deism, the idea of a personal God. But I think
can you put the microphone closer?
Most sophisticated people that believe in the idea of a personal God expect null results in prayer studies for very obvious reasons. I mean, C.S. Lewis wrote a very distinguished essay on precisely this. Martin Gardner, another theist, wrote a very distinguished essay in the Whys of a essay in his book, The Whys of a Philosophical Scrivener. So it happens that there are large tracts of human experience that are subjective or intersubjective, and they're not formally scientific. Ram and I had a conversation some years ago when we met. That conversation is completely out of the domain of science. I mean, it might be rather difficult to document when we met, what we said, when we met, where we met. It'd be rather difficult. I mean, we could do some science on it like a detective would. But fundamentally, a lot of human interaction and people that believe in interaction with a divine being, they would say that this kind of interaction is not objectifiable. Now, you could say that's a dodge. But this would be actually very well developed within theologies, and those theologies, for centuries as well as in modern thought, would critique the idea of objectifiable interactions, such as prayer studies might document or falsify the idea that, say, you could pray money into your bank account, or that if you had cancer, you could pray yourself into health. So I would stick with this affirmation that although there is a culture around science, or philosophies around science, or elements of scientism that put pressure on such beliefs, and in my own life I would certainly testify to that, there actually is nothing in science itself that tends to compel this necessity of direct conflict between scientific praxis, scientific habituation, scientific method, and religious beliefs. And one would find within religious literature, ancient and modern, precisely these debates very well developed.
Sam?
Yeah, I'd just like to point out that you could have made precisely the same. I'm speaking to you, I forgot your name, Charles from Templeton, right here. You could have made precisely the same comment, simply changing a single word from God or a personal God to Poseidon. And without any change in sense, really. And I've said this before publicly, and Richard Dawkins has said more times than he cares to count, I'm sure, that everyone knows what it's like to be an atheist with respect to Zeus. We all reject Zeus out of hand. We would resist mightily any encroachment into public policy that tried to constrain scientific research out of deference to the Iliad and the Odyssey or any other Zeus worship. And you could say no scientific study has ruled out the existence of Poseidon. And yet this analogy, which I'm now drawing between Poseidon and the personal Christian God or the Jewish God or the Muslim God, really strikes theists, Christians, Jews, and Muslims as a total non sequitur. So as an aside, I might say that I now get hate mail from people who actually believe in Poseidon, which is, quite a surprise. I mean, Richard and I confidently trot out this analogy, saying, we all know that Poseidon doesn't exist. Christians or Jews or Muslims like yourself think it a totally spurious analogy, and yet, the hate mail comes pouring into my email box from neo-pagans who I've been called a racist for denying the validity of these religious beliefs. So what you have on your side are sheer numbers of subscribers, 2 billion Christians, 1.3 billion Muslims. That personal God is compatible with an endless amount of progress in science, and yet the mood you feel about Poseidon, the reflexive rejection of Poseidon, is the mood that could extend to the God of Abraham, and should extend.
Jim Woodward. This is Jim Woodward from Caltech.
I was struck by the fact that the neural areas you mentioned in connection with religious and out-of-body experience don't seem to overlap all that much with the. You may have a different view of this, but they don't seem to overlap all that much with the usual suspects that come up when you do a neural imaging of people who are engaged in moral reasoning tasks. So like in the latter case, it's things like insula and orbital frontal cortex and ACC and so on and so forth. And I wonder would you be prepared to draw any conclusions about that, about the relationship between ethics and religious belief? I mean, is it conceivable that you're just looking at sort of two really somewhat different systems here?
Yeah, I mean, we talked earlier about ethics, and I was talking about empathy and mirror neurons. They are found in the frontal structures, but they're also found in parietal structures. And I think one of the mistakes is to assume that if there's a specialized system of neurons or circuits, they have to be localized in one part of the brain. They could be distributed and yet form part of one complex system of neurons. I mean, this is a recurring debate, modularity versus is it distributed. And sometimes it can be distributed in different parts of the brain, but functionally it's modular. And I think that's true of, especially something like religious belief. I think there are many layers to it. There is the emotional fervor connected with it, and then there is the more confabulatory, and again, I don't mean to sound like I'm debunking it, but confabulatory aspect of constructing a story to account for these emotional upheavals in your brain. And there are all the cultural overtones of religion. So it's unlikely there's one little God spot. There are many different regions of the brain involved in many aspects of religious belief. But as a biologist, you want to know what parts are involved. Just saying, the whole brain is involved doesn't get you anywhere. Just as if you say, well, piglets resemble pigs, so the whole pig is involved. But once you get to the chromosome, you know that the chromosome is involved, not the whole pig. So, I mean, I agree with you that it's distributed, but not entirely in the whole brain. There are specific systems which are specialized, including parts of the frontal structures.
Yeah, the hour is late, but there was just one more. Let's take one more question from Darren.
Well, this is more of sort of a comment on the general issue of...
just say who you are.
Yeah, Darren Schreiber at UCSD in Political Science Department, and mixing a little bit of neuroscience in there as well. I have had a sort of divine experience in a number of years ago, and I don't know what part of the brain it was coming through. It was I had a vision at one point that appeared to me to later on in reflection to have fairly deep spiritual significance with my life. And
could you elaborate on that a little bit?
yeah, I had a vision of a passage from the Bible. I didn't know what the significance of it was at the moment. I was meditating. I was doing that every day for a very long period of time to cope with an emotional trauma, and had just a vision of just this set of Bible verses like you see in the top corner if you open up Gideon's. And
were you in a hotel?
No. But I wasn't in a hotel. I wasn't on mescaline, and I don't believe I was having a temporal lobe epilepsy. And I won't go into the whole experience of why that I saw that to be a message to me. It had a number of features of it. This particular verse, when I looked it up later, it was actually like 2 days later when I thought, well, this was weird. I've never had that kind of a vision. I wonder what it means. And then had a Pentecostal about 3 weeks later explain it to me. And when they said what they thought that this meant, I went from being in a very normal affective state to bawling my eyes out. And it was really shocking for me to have experienced something that dramatic of a shift in my own affective state. Having recently gone through another personal emotional tragedy in the last number of months, I've been searching for I was talking to a friend of mine who was a pastor and was talking with him about this. And he said, Darren, sometimes God brings us into the unknown. And I think being in the unknown is a very uncomfortable place for us to be as scientists. I mean, this is what drives us often, is to get out of that place of the unknown. And I thought later about the story of Job in the Bible. And Job in this story is being placed in a horrible position. And he's faced with the unknown. And as I was contemplating that today, I was thinking that there are sort of 4 responses that I'm, I think, called to as a person of faith when I'm placed in the unknown. And one of those is to keep searching. I think that I feel called to keep searching, that we as people of faith are called to keep searching, not to just give up, not to just say, well, we don't understand, but to keep searching. A second is a striving for humility, and that's something that I've felt has been lacking often in the discussions today. If we don't have humility as scientists, it's very difficult to acknowledge when we're wrong. It's very difficult to realize that there's something else that is unknown that should drive us to the next set of hypotheses, the next set of inquiries. A third thing that I feel called to as a person of faith when facing the unknown is to love others. It's, again, something it's fairly simple, but again, also something I've been hearing as lacking in some of the discussion today. I think a lack of respect for the belief systems of others, a lack of the respect for faith that others have, or the choices that others make in their lives. The fourth thing that I feel called to when I listen to the story of Job in the Bible is a call to be present with the unknown, and that sometimes there are just things that we just don't know. And that's something that, again, is uncomfortable. It's not a place I want to be as a scientist, but sometimes everything that we know about science tells us that we're just going to be in that place of the unknown.
Annie?
Yes, I would like to humbly and respectfully disagree with you. My name is Annie Drian, and I'm founder of Cosmos Studios and an honored to have been the longtime collaborator of Carl Sagan. And I'd like to say that I think it's just the opposite of what you're saying from my perspective, humbly. One is that I think that science tolerates the unknown in a way that religion doesn't. My argument is not with people who search for God. My argument is with people who feel that our understanding of God is completed. And those are the people who make so much of our existence on this planet such a hell, because they really think that they have the right to kill other people, to hurt them, because of what they understand God's will to be. That's a very destructive thing. So science is, the whole methodology of science is saying that we are not permitted these absolute truths that religion pretends to have, that we do not know the answer to these questions, and not only that, but the little that we think we do know, if you can prove us wrong, we'll give you our highest reward. And that's part of the methodology. That's part of the whole functioning of the system itself. So yes, in answer to what Joan was saying earlier, scientists do terrible things. Scientists have biases. Religious people do terrible things, and they have biases. But absolutely intrinsic to the whole the methodology of science is that error-correcting mechanism, which says we must never lose sight of that. That's not in religion. That's not present at all. Talk about humble. It's the fact that we do science and that we can bring ourselves to see that little tiny earth in Carolyn's presentation. That is humility. What science has done for us spiritually is that it has been the only thing that I know of that has compelled us to wean ourselves of our infantile need for centrality. And that was present, that is very much the essence of so many religious formulations of where we come from, why we came to be. It's the sign of mental health, that we can bear to think that this planet was perfectly fine for 4.5 billion years without us. That cosmic evolution goes on for 13.5 billion years before we even get here. How long have we been in science? How long have we systematically been looking at nature? Not even 400 years. And yet science gets us out to Enceladus. It takes us out of the solar system. It enables us to wean ourselves of that spiritual narcissism which compelled us to be at the center of everything. So when it comes to humility, when it comes to a tolerance for ambiguity and for the unknown, I think science worships the unknown. I think scientists are most comfortable in that place of not knowing. And that's where they live. And that's the great strength of science. So I would respectfully disagree.
We can go on if you like, but it's 7 o'clock, 7:10. That seems to have been a wonderful note to end on.
Quantum mechanics. To put it in another context, we know that the brain fills in, constructs reality. For example, in the color phi phenomenon. Many of you are familiar with this. You look at a screen, you see red on the left, then nothing, then green on the right. What you experience is red turning to green halfway across. That's what you experience. Okay, no big deal. However, if you do this 20 times in a row, And the 21st time, you trick the subject and it goes red, red. The brain isn't fixed. It goes red, 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 red. Or if it's blue, it goes red, red, blue, blue, blue. Somehow, it seems as though the brain knows what's going to happen. Now, there's a couple explanations for this. Now, I've turned this sideways. So here's the observer looking at the screen this way, with time going this way. So here's red over here, green over here, subsequent in time. So this is what is actually happening. Now, what the observer experiences consciously is red turning to green halfway across. That's just what I just said a moment ago. Now, in Dennett's explanation, retrospective construction or Orwellian revisionism or Stalin-esque show trials, they're all nuances of each other. What he says is that in real time, there's the red and then there's the green, but the observer remembers red, red, green, green, green. So the observer, the conscious observer, is roughly a half a second behind reality. We're living in the past, and we falsely remember unified conscious experience occurring in real time. And this is his position, and this is pretty much everybody's position in mainstream neurocomputation, I believe. However, another possibility is that because quantum information can go backward in time this way, that the signal can actually come from the near future to the present so that we can have real-time conscious experience. Now, backward time it is strange, but in quantum information it happens all the time, and in fact is probably what mediates EPR effects and entanglement, that the signal when the measurement is made goes backwards in time to when they were united and then to the other one. So backward time effects in quantum mechanics is okay as long as there's no causal paradox, as long as nothing goes back in time to kill your grandmother so you can't be born. If you avoid those causal paradoxes, it's not a problem. And since the quantum information is unconscious in our model, then it can't be observed, so there's no causal paradox. So quantum consciousness can get us out of this problem of being a half a second behind reality, living in the past, and having consciousness be an illusory epiphenomenon. So there's been very little said about the quantum world here. Let me just survey a couple things. Basically, reality is described by two sets of laws. We heard about Isaac Newton this morning, but after, starting about 100 years ago, quantum mechanics came in, and physicists thought they had it all figured out. Well, it turns out it was far from the truth. In the quantum world, quantum particles can exist in multiple states or locations simultaneously, quantum superposition, and this is used in quantum computing. Wave particles may remain unified over distance and time, quantum entanglement. And recent studies have shown that entanglement occurs at room temperature or warmer robustly, and that macroscopic objects can be entangled. So it's becoming more and more prevalent, even in semiconductors at room temperature, to have quantum entanglement. And quantum information is time symmetric, backward time. Many people say, well, the quantum world is random. That's not true, at least not. This view of neurocomputation has some problems. First of all, it is incompatible with the best measurable correlates of consciousness, gamma synchrony EEG, and the mechanism of action of general anesthesia. Also, it necessitates rendering consciousness as an after-the-fact illusion, an epiphenomenon with no causal power. As Thomas Huxley said, we are merely helpless spectators. And it precludes any scientific possibility of non-local interconnectedness, fundamental morality, and deeper meaning, the soul. Now, we could argue endlessly about these two things. And we've heard arguments that there is no such thing as a soul, and all this is a bunch of rubbish. And maybe we are helpless spectators and don't have any real-time conscious control. Maybe consciousness is an illusion put together after the fact and inserted in a memory, as Dan Dennett has described it. And it's difficult to prove either way on this, as we've heard. However, let's look at the science. Let's look at these problems that I'm claiming exist with neurocomputation for gamma synchrony EEG and general anesthesia. Now, in addition to chemical synapses, there's another type of electrical synapse in the brain and nervous system, electrotonic gap junctions. These are electrical synapses. They form between dendrites, dendrite to dendrite, for example, also glial cells, and in some cases axons. And they make a different type of network within other networks within the brain. Here's a close-up, but you don't actually see it, but these are hollow cores. So these gap junctions are like docks docking modules between spaceships, if you will, so you could swim, if you're really small, from one neuron to the other. And these are, of course, the microtubules where Roger and I think consciousness is actually happening. But the point is that these electrotonic gap junctions are what mediate gamma synchrony. Specifically, dendritic gap junctions mediate gamma synchrony, the best neural correlate of consciousness. They form what you might consider as dendritic connections or lateral connections, shown here in this slide from Cahal's early work, and then dendritic interactions between pyramidal cells and interneurons and others in the cortex. So and they come and go. They form a connection, they disappear, they come and go. So transient webs of dendritic gap junction connected neurons and glia can extend widely through cortex, and they mediate gamma synchrony. And I claim that this is the neural correlate of consciousness, these transient webs. And this idea was put forth by Sir John Eccles and Carl Prevram, that consciousness occurs in dendrites with axons providing input to and output from where consciousness is occurring. So if we look at a regular group of neurons with dendrites here, fire a spike, trigger this one, goes around in this circle. Obviously, there could be a lot of parallelism and so forth. But just if you were measuring, you'd see this voltage potential kind of traveling around. There's no coherence. Spikes are not coherent. However, the dendritic gap junction connections do give rise to gamma synchrony. So anywhere in the system where you measured, you'd see gamma synchrony. Where you have the dendritic gap junctions, there could be some glia involved, and so forth. So the point is, the best neural correlate of consciousness, gamma synchrony, depends on dendritic gap junctions, not neurocomputation as we normally think of it. I'm an anesthesiologist, and I put people to sleep every day and wake them up. And the best study that I've seen on brain monitoring during anesthesia and loss of consciousness was done by Eroy John and Leslie Pritchup last year. And they showed that loss of consciousness with general anesthesia correlates with loss of gamma synchrony between frontal and occipital cortex. So here's the absolute power in F3 and O1. So a frontal lead and an occipital lead. And just to cut to the chase here, if you look, this is induction. So the patient's awake, they go to sleep, loss of consciousness, they're maintained under general anesthesia, they begin to return to consciousness, and then they're fully awake. And the one thing that stands out, as you can see here, that correlates with consciousness is the coherence between the front of the brain and the back of the brain. And this is quite robust, and it's been repeated in rats, and of course we don't know for sure the rat is conscious when they wake up, but the point is that front to back and cross-hemisphere coherence in the gamma synchrony range is the best correlate of consciousness. Now, gamma synchrony derives from coherent conformational oscillations of dendritic membrane proteins regulated by quantum London forces. So what I'm saying is that if you have dendritic membranes in different parts of the brain oscillating coherently, that means their voltage channels are oscillating coherently, and they are anesthetic sensitive proteins, and that means that their conformational state is controlled by electron dipoles within what are called hydrophobic pockets. And if they're in one orientation, the protein is in one shape. This could be an open channel, this could be a closed channel. It goes back and forth, coupled to the movements of these electrons. And these are quantum mechanical forces. Anesthesia, anesthetic gases work only by quantum forces. They form no chemical bonds in the body, and they're also quite selective. Patients under general anesthesia are unconscious, but if you do evoked potentials or measure EEG, their brains are quite active. We use evoked potentials all the time in spine surgery, and the brain is neurocomputing away in the absence of consciousness. What does disappear only is the gamma synchrony. And so anesthesia is selective for consciousness, sparing other brain functions, and they bind only by quantum interactions, quantum forces called London forces. So the other problem with gamma synchrony is that besides it not being mediated by conventional neurocomputation, it is not driven by thalamocortical pacing, recurrent feedback, reciprocal action potentials, and or synaptic transmissions. As I said, gap junctions, while necessary, cannot account for the zero phase lag coherence, the perfect, as far as one can measure, between front and back. So here we have gamma synchrony, and basically what's happening is that proteins in the front of the brain are oscillating coherently, and proteins in the back of the brain are oscillating coherently. And Walter Freeman and Giuseppe Vitiello, and in a separate paper, E. Roy John, concluded that normal neural processes shown here cannot account for this synchrony, and that some quantum effect must be at play in the brain to account for gamma synchrony. And even if you deny that gamma synchrony is the best neural correlate of consciousness, it does occur, suggesting that something funny is going on. And quantum correlations, entanglements between the front and the back of the brain, mediate gamma synchrony and consciousness. And Walter was, as you probably know, is no big quantum fan. He just came to this conclusion by studying it. And I recommend this paper. Actually, I didn't put the citation, but I can send it to you. Anyway, proteins switching between two states, depending on quantum forces in their core, is the basis for the model that I developed with Roger Penrose, in which microtubules inside the neurons, particularly within dendrites, are performing quantum computations with themselves, with each other, and through gap junctions throughout the brain to account for consciousness. So if we were in this neuron looking through the gap junction, we'd see this other neuron. And if there were another gap junction here and here and here, this could spread throughout the entire brain. And one could have one continuous interior where quantum states could be protected and isolated and avoid decoherence. And this is something what it might look like with quantum states spreading between, from neuron to neuron through a gap junction. So that was the story about anesthesia and gamma synchrony, which neurocomputation has a problem with. The other issue that I want to address that's more arguable in both directions is, are we helpless spectators? It's been known for many years. Max Vellman's published in 91 on this, and Dan Dennett had it in his book in about that time. Evoked potentials apparently occur too late, 150 to 500 milliseconds after sensory impingement, to account for responsive actions initiated or completed within 100 milliseconds. So in other words, by the time we figure out what somebody said, or by the time we figure out what's happening, we've already responded. Normal conversation, choice planning of execution of voluntary acts, hitting a baseball pitched at 95 miles an hour. A guy wrote a book that says it's impossible consciously, even though the batters think they see the pitch at least halfway. So consequently, so subjectively, we feel as though we perceive and respond to these perceptions consciously. Consequently, subjective feelings of conscious control of these behavior is illusion. They are merely non-conscious reflexive responses. Dan Wegner, Dan Dennett, Terry Serjanowski said something to that effect in the U.S. News and World Report article a couple weeks ago. Accordingly, consciousness, according to the party line, neurocomputation, is epiphenomenal. And we are, as Huxley said, conscious automata, helpless spectators, like Pac-Man. We're being controlled by, in this case, our unconscious selves, and we only think that we're conscious, and it's imprinted in the memory that we were in control. That's Dan's idea. So is there any hope? Well, yes, and there's also data. And this is very old data from Ben Libet, and many people in this field are familiar with this set of experiments, which still defy easy explanation. Basically, he had patients having neurosurgery, craniotomy, with their brain exposed, but under local anesthesia so he could talk to them. And for example, he could stimulate the finger area of one cortex and also the same finger on the other side. And basically what he found was that direct cortical stimulation, if it resulted in what looks like gamma synchrony for 500 milliseconds, resulted in consciousness at the end of half a second. But if you stimulated the finger and got an evoked potential followed by 500 milliseconds, it was felt at the time of the evoked potential. Now he did some other studies with thalamic stimulation, which basically said that if you have the evoked potential but don't continue with the gamma synchrony for the full time, there's no conscious experience. So somehow it appears as if the brain or the body or somebody knows whether or not this is going to continue. Libet concluded that there's backward time referral of subjective experience from the time of what he called neuronal adequacy to the time of the evoked potential. Now, backward time is perfectly permissible for quantum information.
So, at some point, consciousness had to come into this. And I can think of no one better to introduce consciousness at this point especially because of the, at least at the level at which Stuart wants to talk about it, and because of his work with Roger Penrose as well. Then Stuart Hameroff. Stuart Hameroff is anesthesiologist, director of the Center for Consciousness Studies at the University of Arizona. And some of you here must have been to these Tucson conferences on consciousness. And Stuart was the lead organizer for those things and did a fantastic job of really getting us all thinking about these sorts of issues. He has collaborated with Roger Penrose on the development of what they call the OR theory of consciousness, which he may well explain in passing. And I think you're going to connect everything that's been spoken about so far into one little package, right?
I'm going to try.
Okay.
Thank you, Roger. Thanks for inviting me. Thanks for still being here, everybody. Well, so far, to my way of thinking, most of this conference has been kind of like the Inquisition, but in reverse. The scientists are kind of frying the people who believe in religion. And I personally am not fond of organized religion, and I don't have a problem with bashing organized religion. However, I think that there is room in science for scientific spirituality, basically an interconnectedness, a fundamental reservoir of Platonic ethical values embedded in the fundamental level of the universe. This is the idea that Roger Penrose put forth in The Emperor's New Mind. And he doesn't go so far as to relate it to anything spiritual or religious, certainly. He kind of stops. But I think it's fair game to take what he said and extend it to some kind of underlying aesthetic and ethical Platonic values embedded in the fine structure of the universe. But then one must show how this level can connect to our relatively macroscopic brains. So with that in mind, the title of my talk is somewhat tongue-in-cheek, Quantum Consciousness Can Save the Soul. By soul, I mean this kind of spirituality, interconnectedness, and Platonic values embedded in the universe. So Descartes, of course, prior to Descartes, religion and science were pretty much on the same page in most things. And then Descartes, who said, of course, I think, therefore I am, the fact that he was conscious was the only thing he could be absolutely certain of. But consciousness, as we all know, is unobservable. So this gave rise to dualism. And it's kind of continued, actually. Those in neurosciences tend to explain away a lot of the things about consciousness. So the scientific aspect of this led to what we might lump as neurocomputation, basically brain equals mind equals computer, in which neuronal axonal spikes, synaptic transmissions are fundamental components like bit states and switches in computers. And some of the giants in that field are in this room. And this is based on dendrites receiving inputs from an axon, integrating and then firing to the next one. And with the chemical synapse being the fundamental unit in most ways of looking at it. However, as an explanation for consciousness,